And it's not just mechanical, there's electronics, there's software, there's batteries, cars are now connected, they're online. But how is this complexity impacting how cars are designed? There's this vast amount of data that has to be managed, but before it can be managed, it has to even be created. With us today is Siegmar Haasis. He's the CEO of Digital Engineering Consulting and the former CIO at Mercedes. And he has a vast amount of experience from toolmaker to virtual reality. And you couldn't find anyone better that can give us a little bit of an idea based on his experience in all these different areas of what the challenges are in the automotive industry and what that really means for engineering. Ziggy, welcome to the Future Car Podcast. Well, let's start off with this. What are the most important market trends that are reshaping the auto industry's future?
Concerning megatrends, I do see, let's say, three pillars. First pillar, definitely, it's e-drive. After 150 years of combustion engines, now we have a game-changing to BEV, to battery electric vehicles, to hybrids. Perhaps in the next generation, it's the fuel cell. So that's the powertrain change from combustion engine to battery-driven cars. First. Second, I do see the in-car software. So from we can see currently a lot of music in vehicle operating system. So Mercedes is calling this Mercedes-Benz operating system or Volkswagen operating system. Tesla has his own operating system. Autonomous driving, automated driving is part of this in-car software. So a huge second pillar of a megatrend. The third one, perhaps not technology driven like the first two of them, I call it market regulations. Market regulations means starting with the CO2 or WLTP from a range perspective, or now software update management system means you have to be compliant with new laws and software update management system. For example, means also connecting to the software. Each time you have to show transparency which kind of software levels, software bundles are in each and every car instance.
So when you think about engineering the car, you have a lot of things that are competing against each other. So you're going to electric drive, that to get more range, it drives you to have more batteries in it. But then at the same time, you're putting more features into the car. And those features, big screen, like you mentioned here, is going to take more power, which means even more batteries. But then you try and make it more aerodynamic. You try and take weight out, look at different materials, whatever it might be. What do you see the biggest challenges in how all these things are coupled together, intertwined?
So, from my perspective, the whole behavior of a car, let's call it the soul of the car, is more or less represented by the ECUs. So a luxury car like a Mercedes S-Class has up to 150 ECUs. In the past, all these 150 ECUs, from braking to the wiper to the telematic, has been discussed, has been described and shipped to the vendors. So therefore, in 3 to 4 years, all the ECU vendors developed software-coded, spaghetti-coded hardware and software. At the end, they shipped 150 ECUs to the OEM. And then the problem for the OEM, how to integrate these 150 black boxes, the ECUs in the car, with 150 small mini computers, behavior, spaghetti coded hardware and software, because then everything is fixed. You can't move, you can't change, you can't do an upload or a big, let's say, software modification. This will dramatically change to one computing system, one big computer with a reference architecture. And the idea from the OEMs was, to develop now the whole software for the vehicle operating system by themselves. And therefore they asked they wanted to hire 2,000, 5,000, 10,000 software engineers in order to develop this software. But you can't find this 10,000, 20,000 software developers not in Germany or in Europe, nor in the US, nor in Asia. So therefore, still you need collaboration with the vendors. But the whole concept is completely different. Now, organized in domains or in zones, you have one main computing system and not 150 pieces and hardware boxes. So therefore, it's a split of hardware and software. And the software part, you could continuously motivate. You could, let's say, you could download new features and even sell additional money by, let's say, updating new features over the air. And that's the big shift. I would say this is a game changer for the future.
So as the car gets this additional complexity, as it becomes more digital and people start to expect more, how do you keep up with what customers want? Because in the software world, you have updates on an ongoing basis. And I would imagine now people are going to start expecting that in their cars. They're not going to want to wait 5-7 years to see the next version. How do you figure out what it is the customer really needs and what they're going to need next? How do you do that?
I guess this is really, and I recognize this shift as well. This is, let's say, the shift from engineering driven to customer orientation. Engineering driven means I'm expecting the customer wants to see this. This is now changing to put the customer in the middle of the process. Ask the customer, involve the customer in each and every innovation. Therefore, we established, and this takes place in each and every OEM and first, second tier suppliers. It's, let's say, this agile process to come up easily and fast with the first minimal viable product. Just to try this out, involve from the beginning the customer and ask them, do you need this? Do you like it? Are you willing to pay for this? And this customer orientation, which is next after, let's say, engineer decision. Now it's a customer push, customer first, involve the customer. This is definitely a game-changing process to, at the end, to come up with the products the customer love and the customer is willing to pay.
Now, how do you do that? Do you actually bring the customer to the factory and have them take the car on a track or test drive?
Yeah,
or something?
so it depends. It depends. So, I mean, the decisions are made on different levels. So, for example, in the beginning, you start with requirements and styling. Styling means a new shape, and if you create a new shape in the styling department, everything is top secret. You want to ask some first customers, already Mercedes customers, but also customers from competitor cars, and ask which one you like best, right? And so we have done in the past, we called this design clinic. And this
how do you find
done,
how do you find the competitors' customers? Do you go to the BMW dealership and wait outside and say, "Come with me"?
No, this has been done and organized, let's say, in three parts of the globe. So one is perhaps in California, one was in China, one was in Central Europe, and there you are just asking, let's say, representative customers, own customers, or customers from BMW or Tesla or Rolls-Royce or whatever, depending on your focus, and then you're inviting them. And in the past, along this design clinic, we have shown hardware clay models in the very beginning. But because of the digitalization, this has been changed to VR and AR. So therefore, with the head-mounted display, you haven't to ship hardware to California, to China, or somewhere else. You have the VR AR, and just ask the same audience which one you like best. And therefore, this is just one example how you can invite and involve customers or potential customers in very important design decisions. So this is just an example for design, for styling.
So speaking of data, we hear this term digital twin thrown around. And so it's a virtual model, a duplicate of what's in reality. So that's explain maybe what the digital twin is, how it might fit into what you were just describing, and how it's important for taking cars, the design of cars from where they used to be to this more complex version of them.
So first of all, let me start with a definition. My understanding of a digital twin means a digital representation of the car itself, the vehicle. That means the form, the shape. It's the digital representation of the function and of the behavior. It starts from scratch, from the requirement, from styling, engineering, production, sales, after sales, down to the usage of the car. So therefore, it's an end-to-end process, and have there the digital representation of everything. That's the digital twin. Or now I would use the plural, the digital twins, because different, let's say, perspectives and dimensions. Everything is represented digitally. If you have to build this, currently you have hundreds of backend systems, such and starting in the engineering like CAD and PDM and BOM, bill of material, and electric and electronic system. You have production systems, you have sales and after sales systems, but you can't revolutionize all of them. You can't build them from scratch and to do everything from new. Therefore, you need access to all of this data. And perhaps based on a data catalog, you are defining which is the most important data you need access to. So therefore, it's a kind of three-level approach. First level, that's let's say the foundation. You need access to all of your backend systems. This is, let's say, the base, the foundation, the bottom. Middle layer, I call the data layer. The data layer means using your APIs, and you should use their one standard API, having access to the data, and let's say organize the data with data orchestration, API management with the microservices, and push them to the top. And the top are cockpits. Cockpit means it's role-specific cockpits. So like I mentioned, you have different roles in engineering, like the system engineer, the component engineer, the designer, you have the production planning engineer, so different roles along the whole process chain. All of these roles are using different applications and systems. What does this mean? Every day, one of these engineers, let's use the component engineer, he has to use around 10 different systems. So every day he has to type in these 10 systems to do his job. The idea of the digital twin helping him not to insert, to input, to deal with his 10 expert systems, but just having access to his cockpit. And in the cockpit, all the data he needs to fulfill his tasks are organized there, orchestrated there. So it's he can read it and he can modify it. So easy to use. He has there the workflow organized, and this is really helping him to speed, because it's all about value. And value creation means three things. It's speed, it's time, and it's cost. And the digital twin helps him, to accelerate the whole process by also using the calculation, the simulation, the CAE to check, to do the digital validation of all his products, components, systems to speed up the whole process. So it's all about speed, You know, all of the OEMs currently are using 4 years for a whole product creation process, and they want to accelerate to whatever to reach 3 years of product creation process time. They want to reduce the cost, and mainly the cost factor is the hardware cost, the hardware prototype cost. Also, there the digital twin is helping to reduce the hardware prototype cost. And then it's quality, it's the product maturity. So for me, the digital twins is the most important thing, the first step for the digital transformation, attacking exactly these three areas and dimensions: time, cost, and quality.
So speaking of collaboration and getting along with people, you once, when you were running an R&D team, hired a psychologist. Now, why'd you do that? And more importantly, after you hired the psychologist, what did you gain from it? Did it work out? Was it worthwhile to do? Should we be hiring more psychologists to help our engineers get their work done more quickly, more efficiently?
I mean, to be honest, really, that happened 20 years ago. 20 years ago, when I started a new organization in the research lab in Ulm, responsible for engineering and new methodology. That time we started our Daimler Chrysler organization. And what we found out there is there's really a problem in this collaboration. So if we have teams, cross teams of Americans, Asians, and Europeans, it's really an issue when is let's say the light color red, yellow, green. So it's a different interpretation, or is a yes or a no. How to collaborate? How could we understand the different cultures? Cultural teams is important. So therefore, because really we had a lot of issues in this intercultural collaboration, we said this is one focus. A second focus, yeah.
Can you give us an example of an intercultural conflict as it applies to engineering? One that stands out for you.
Yeah. So you know, perhaps two examples. One example, at the end, we have to define what is the status of this project. And the Asians are saying, hey, it's green. And perhaps the Americans or the Germans say, no, it's red. We have issues, we have problems. So therefore, what is red? What is yellow? What is green? Do we have the same understanding of when is it critical? When we have to escalate? When we can handle within the team? When we need the external support? When everything is running well? Different interpretations, different cultural whatever interpretation. Or the other one is if you're in a discussion in a project, perhaps all of them used just a common call and ending up with, okay, this is the situation. Some of them says, okay, this is now the decision. The other one is the yes was just, I understood, but no commitment. So therefore, what does this mean? A yes is a yes. Yes, I understood.
Is it a real yes or not?
Or is it yes, I understood and I will do? So therefore, just the two small examples. What does this mean to understand the different cultural behavior?
Yeah, and sometimes it is as simple as you just said. Was that a real yes? Does that mean they're going to take action? Or was it a maybe, I'm going to think about it? And those are important things to know. You said something earlier that I think is really important. In part it's communication, but more it's how you work. And that's this whole idea of innovation and the willingness to take risk. Sometimes taking risk can be dangerous because you can make a mistake, and mistakes could be looked down upon, but sometimes you have to make 4 mistakes to get that 5th one to be right. But people may be averse to making mistakes because, oh, if I make a mistake, I might not get promoted. So how do you change the culture so that people are willing to make mistakes, because that's the key to innovation.
Mhm.
How did you do that?
It's not that easy to establish this new culture. But if there is the willingness from the top to establish a new culture, then we could start. But it's important to walk the talk, not just let them know and let's change the culture, because changing the culture, it's not a sprint, it's a marathon. And you have to walk the talk and to start first, I mean, with the bosses to let them know now there's the big change. There's the big change. And if there is a mistake, if there is an error, not hide it, but explain it. We started to do some presentations, not just the success story presentations, not just the nice, the beautiful things to share what we could be proud of, but also let's share when I made a mistake, and celebrate celebrate this as well. Celebrate this to be honest. So honesty, to be transparent, and let them know, hey, and starting with the boss, I made a mistake, and I will share this with you, just to make sure, perhaps if you are in a similar situation, then you know I made there a mistake. Perhaps you can do the better decision. And you will do also mistakes, and that's okay, but take action. Take action, feel responsible, and speed, speed, speed. Otherwise, you will not have the speed. Otherwise, you will not have the innovation. Otherwise, you will not have this whole end-to-end cross team. If you are just forcing people to do everything right, and if you have problems, issues, just kill them. So that's not a way to establish a innovative culture.
When you were at Mercedes and this complexity grew, maybe could you draw maybe some examples from there on things you did with engineering tools to start to handle this complexity as it grew over the years?
One aspect is the easy to use of the software system. So most of the systems are, I would call it more or less expert system. So really hard, and you have to train the people for a long time, because they're really very, very complex to use. So therefore, even the task is not that easy. The behavior or the way to use it should be really easy, should be intuitive. So this intuitive behavior, this easy to use, is important. Therefore, you have to understand the way that the experts want to behave, and to do the next steps, and to follow the process, and to organize your tools like, let's say, the human being decision process. That's important. That's the intuitive way to guide them, to have a kind of assistant, to use AI for, let's say, what could be the next best action, already to help and to support. No long searching list, but everything should be automated. And again, I'm coming back to the digital twin. Using a digital twin, he is doing already all this searching, all this preparation, all this, let's say, manual things. The idea is, let the expert focus on, let's say, the higher level decision making. The whole manual thing, the whole searching for the right information should be done by the application. That means you have to make sure the whole information is flowing from engineering to planning to production to sales and after sales. So therefore, you need, let's say, this data flow, this information flow. You have to avoid proprietary interfaces, just easy to access to these applications and tools. And then the behavior of the tools itself is a kind of platform. It's easy to use, and you can just pick this functionality which is needed, not the, let's say, the whole package, only only this functionality which is needed to fulfill your job. So therefore, easy to use and let's say AI support, assistant support is really important.
If you think about several of the things that you just mentioned, best in class, so the individual things have to be really good. It's best, you'd like to take, this is good at this function, or this solution is good at that. But then you also want solutions that go end to end. So you have to have a lot of solutions. But then, most important part, there's your building blocks. Now you have to make it happen. And then you need support, because you can't just it's not like Legos, you just give you the pieces and you put them together. There's always going to be issues when you connect things together. And so can you give an example from when you were at Daimler?
Yeah, I mean, I have done many big projects. One of them was the migration from CATIA to Siemens NX. That was a huge program, and we started to change. I've learned it's really important to communicate again and again why we are doing and starting this huge program, this huge project. And start always with the why. And why means the value creation, which is cost, efficiency, innovation, whatever, and what's in for me. So we need the acceptance of the audience and of all of the involved partners. And then we have started, this program for the 3-4 years, and for such kind of big programs, you need really a partner you can rely on. But we had really issues after 4 years, because the maturity was not like defined and like hoped, and we had to do an extra round, and this really helped me. To be really close to the top management there. We had their issues, we had their really tough discussions, but at the end it was a success story, because at the end the Siemens NX tool was automotive ready.
When you connect things together that have different data formats or whatever it might be, knowing that you have someone that can fix those problems seems to me a really important thing to look for when you're running a big organization with a lot of solutions.
But see, if the question is how would I select, what are the decision criteria for a software, there are different aspects. First, definitely, it's the functionality. Second is, like we discussed, the easy to use. The third is how easy I could integrate this solution, this service in my existing landscape. Because in 99% it's brownfield and not greenfield. Brownfield means there is already a existing IT software landscape, and how could this new thing fit in the whole ecosystem, in the whole landscape? So therefore, does this new software, this new application has APIs, easy to use connectors, making sure the right data standards, the formats are supported, and the performance of the data. At the end, if it's a critical software, beside all these aspects, there is one more decision criteria, and this is, can I rely on the partner? Can I rely on the partner if this is really a risky thing, and if it comes to really to a task force, to an issue, can I rely on this partner, and is there trust and confidence to this partner?
If you're looking back on your career at Daimler and all the decisions you made all those years, if there was one decision you'd want to change or something you'd want to do better, what would it be? If you could go back now and like say, oh, I wish I would have.
So now we discussed a lot of functional topics, not personal topics. I mean, it's more from a personal background because I spend a lot of time also to support people, to be the mentor to mentees and give them advice. One thing I would do in a different way, and this is I would go abroad sooner. I would go abroad sooner, and this is exactly what I advise my numerous of mentees. Um, I I decided to go to Asia. Let's say in my in my last third of the career. Now, if I would start from scratch, I would start immediately in going abroad because going abroad means your learning curve is much higher, and this I would advise to all of my mentees.
Yeah, and that's been a constant stream through our discussion. Intercultural differences, the engineering level, at the customer level. There's nothing better than getting firsthand experience.
Yeah.
Last topic. Everyone wants to know, when are autonomous cars going to become a reality? Talk a little bit about how you see autonomous cars, all these other pieces we've been talking about. How are they going to evolve over the next 5-10 years? What do you see out there for us in the world of the automotive industry, in mobility in general?
Talking autonomous cars, first I would distinguish between cars and trucks. Why? Because different business cases and different use cases. I would distinguish rather between regions, weather conditions, road conditions. Anyway, let me try to give some outlook from my perspective. Let's start first with autonomous trucks. I think in the next 2 to 3 years we will see autonomous trucks, fleets driving on the highways, hub to hub, transporting goods, especially in the US, in Europe, in China, where we can see the first pilots already, autonomous trucks. In the past, we heavily discussed the term of robot taxi. I don't see lots of customer value for so-called robot taxi.
Now, why not? Why not?
I do see robot taxi. This is more. I mean, I do see some aspects for a people mover, but these are slow-moving shoebox like people mover, and for special use cases in whatever, in special areas, definitely I could see such kind of people movers, yes. But for the cars, and coming back to your robot taxi question, for the cars, the people driving a car, they want to steer still the car. So cars with the steering wheels will gradually evolve from today's autonomous driving level 2.5 up to level 3 on a larger scale in the next, I don't know, 1 to 2 years. Like Mercedes started with the Drive Pilot. So the Drive Pilot allows you up to a speed of 60 kilometers on a highway to drive automatic. And this is, there is a certification and homologation acceptance. So therefore, I do see there the next steps, but still with a steering wheel. So that means step by step climbing up the ladder from autonomous driving 2.5 to 3, perhaps in the upcoming 3 years to level 4, which includes higher speeds in all weather conditions. I do see there, but still with the steering wheel. The robot taxi I do just see in this people mover activity, not on the car side.
Right, not in the individual owned car.
Yeah, exactly. Because see, in the past we discussed connected, autonomous, shared electric. From these four use cases, one is gone. Autonomous still there, or connected still there, autonomous still there, but this sharing aspect, from my perspective, more or less gone. So I do not see a lot of activities in the sharing, in car sharing. So there is not really the big need for this, and if there is not this huge customer requirement, you can't make money with that. And we have seen a lot of activities. All of the OEMs started their own business in ride sharing, in car sharing and activities. Now most of the activities stopped. So therefore, at the end, the customer decides what kind of innovation he wants to see, and he's willing to pay.
Yeah, and a lot of those innovations could be on the software side. I know with Tesla, you can say, oh, for $3,000, we'll give you the advanced driver assist or whatever it might be. And now cars are even starting to add hardware that you can turn off and on. Do you see some sort of a subscription? And I'll give you an example, heated steering wheel. So I'm here in Boston. I don't want that heated steering wheel in August and September, June, whatever. I just want it from December to February, and I'll pay you for that. And then in the summer, I'll pay you for the air conditioning or whatever it might be. Oh, I'd love to have better this or that in my car just for a while or just to try it out. What do you think about that whole a car as a subscription? A Netflix car almost.
I mean, see, the good thing is for software, and definitely from software perspective, I fully support the idea. So download or activate software streams already in the car, not a problem, because there is no problem from a sustainability perspective because it's software. It's software. So all the resources could be used, right? But for example, if you start with a full package and just use 10% of the hardware, 90% of the hardware resources are in the car, but you are not willing to pay and you are not using this from a sustainability perspective, from a resource perspective, makes no sense. So therefore, at the end, it's a kind of combination. But there are really cool cases from a software perspective, from a behavior perspective to download, and also the willingness to pay for this. Ola Kalenius mentioned he want to earn until 2025 €1 billion for software and data products. Yeah, and that's the way I guess all the OEMs are now focusing on.
Ziggy, thank you so much for joining us on the Future Car Podcast. You know, we look at cars sometimes and we say, oh, I want it to be autonomous. I want it to be electric. I want it to be connected. And we don't think about what engineers have to go through to make that happen. And you've certainly given us a great idea today of the other side. What does it really take to make a car? What are the challenges engineers go through? Thank you so much for opening that up for all our listeners.
Ed, thank you so much for this nice interview.